This is this is the video for Friday, April 3rd for pre-calculus. It is practice with sum, difference, and double angle formulas. So I'm going to do around 5 problems, possibly 6, and you're going to have to complete the sheet for homework, which will be due Sunday night. So number 1, you should have this in front of you. Pause it if you have not printed this out yet, but it's nice for you to have it. So number 1, I'm going to do on separate paper to give me more room. Which expression is equivalent to, this is number 1, sine of 22 cosine of 18 degrees plus cosine of 22 degrees sine of 18 degrees. Well, this is really like sine A cosine B plus cosine A sine B. So I said 22 is A and 18 was B. Then I have to look to my sheet and I look here to say which one has sine A cosine B plus cosine A sine B. Well, it happens to be x's and y's here. Sine x cosine y plus cosine x sine y is the sine of x plus y, or the sine of A plus B. So this is really equal to the sine of A plus B. So it's really the sine of 22 plus 18, which is the sine of 40 degrees. And the sine of 40 degrees on your sheet is choice A. You need to show work. Okay, work must be shown. Don't just circle the answer. Number 2, the expression 2 sine 30 degrees cosine of 30 degrees has the same value as what? Well, this is really like 2 sine theta cosine theta, 30 degrees being theta. Well, if you look on your sheet for the double angles, which one is 2 sine theta cosine theta? 2 sine x cosine x is the sine of 2x. So it's the sine of 2 theta. So the sine of 2 theta is really the sine of 2 times 30, which is the sine of 60 degrees, which is the answer, which is choice C. Number 3 is different than the other ones. So that's cosine squared 40 degrees minus sine squared 40 degrees. Cosine squared minus sine squared. Cosine squared theta minus sine squared theta. Cosine squared here. Cosine squared theta. It's looking blurry. Cosine squared theta minus sine squared theta is cosine of 2 theta. X and theta, they're just a variable. So it's cosine of 2 theta, right? This is equal to the cosine of 2 theta, which is the cosine of 2 times 40 degrees, which is the cosine of 80 degrees, which is choice C. If you were to check these on the calculator, they would work out as well. Okay. If it was a multiple choice test and it was a Regents, that'd be one thing, or multiple choice anywhere, but when it's not, you have to show work. So that was number 3. Okay. So I did 1, 2, 3. Now I'm jumping to number 5. Now number 5, 6, and 7 end up having the same triangles in the beginning. So once we do that, it's going to help you with the other two. So number 5 says the sine of A is 4 over 5, and the cosine of B is equal to 8 over 17. And they want us to find the sine of A minus B. But very important, it's said in the question for number 5 that A and B are positive acute angles. A and B are positive acute angles, which means they're in quadrant 1. So here's A. Sine is opposite over hypotenuse. And if it's a Pythagorean triple, so that makes that 3. If not, you could do the Pythagorean theorem and say x squared plus 4 squared equals 5 squared. The cosine of B is adjacent over hypotenuse. And if you do the Pythagorean theorem here, you end up with 8, 15, 17, which is also a Pythagorean triple. Okay? 8, 15, 17. Sine of A minus B, if you look on your sheet of the sum and difference, the sine of x minus y is sine x cosine y minus cosine x sine y. So sine A cosine B minus cosine A sine B. Sine of A, opposite over hypotenuse, is 4 over 5. Cosine of B, adjacent over hypotenuse, is 8 over 17, minus the cosine of A. The cosine of A, adjacent over hypotenuse, is 3 over 5. And the sine of B, SOHCAHTOA, opposite over hypotenuse, is 15 over 17. So I have 32 over 85 minus 45 over 85, and I end up with negative 13 over 85, which is the answer to number 5. Okay? So now we did 1, 2, 3, and 5. 6 and 7 are based on the same triangle, so that's going to be much easier for you. I wasn't going to, number 8 is challenging. I'm going to do number 8, and then I'm going to do number 11. So number 8 is a challenging one. Really only difference is the radical, but it's actually done the exact same way, and you are in pre-calc. It's not really that bad, but I'm just being nice. If secant of x equals the square root of 5 over 2, I mean, there was a secant in it, and that's in quadrant 4, and the tangent of y is equal to negative 1 over 3, and that's in quadrant 2, and they want us to find the sine of x minus y. Well, here we go. If secant is square root of 5 over 2, the reciprocal of secant is cosine, so the reciprocal of this is 2 over the square root of 5. Quadrant 4 is here, the part of the bow tie that's there. Here's x. Cosine's adjacent over hypotenuse, 2 over the square root of 5. If I do the Pythagorean theorem, 2 squared, I'll actually do it over here. 2 squared plus n squared equals the square root of 5 squared. If I do it all out, I get n equals 1. Okay? Over here, tangent of y in quadrant 2, here's y, and this is now 1, but it's down, so it's really negative 1. Over here, the tangent of y is opposite over adjacent. It's 1 and 3, but the negative goes here because left is negative, up is positive, down is negative, and the diagonal ones are always positive. If I do the Pythagorean theorem here, 1 squared plus 3 squared equals r squared. You do it all out, and you get r equals the square root of 10. So now when I do the sine of x minus y, well, here, I'm going to go up and down here. The sine of x minus y is sine x cosine y minus cosine x sine y. Okay? So the sine of x, here's the sine of x, opposite over hypotenuse, negative 1 over the square root of 5. And in the fourth quadrant, sine should be negative because ASTC, right? The cosine of y is adjacent over hypotenuse, negative 3 over square root of 10. And again, cosine in the second quadrant is negative. Minus cosine of x adjacent over hypotenuse, 2 over the square root of 5. And the sine of y is opposite over hypotenuse, 1 over the square root of 10. So I have 3 over the square root of 50 minus 2 over the square root of 50 is equal to 1 over the square root of 50. So all of that is correct. You could take a picture or pause it at any time. This is a video to help you do that. Okay, now, if I don't like my answer as 1 over square root of 50, I could say, you know what? I want to change it, multiply by rad 50 over rad 50, and end up with a square root of 50 over 50. And the square root of 50 is the square root of 25 times the square root of 2, which is 5 radical 2 over 50. 5 goes into 50 10 times, rad 2 over 10. So rad 2 over 10 is equal to 1 over square root of 50. So we could leave it like this, or we could do it like this if you want as well. That was number 8. And so we did 1, 2, 3, 5, and 8. And I'll do one more, number 11. And you're going to have to do the other 6, okay? Cosine of theta is equal to negative 3 over 5. And then want us to find the cosine of 2 theta. So, double angles. When it's cosine of a double angle, you have to choose the one that's right for you. Well, in this case here, they told us that cosine of theta, that's all we know, so let's use the one with cosine only. 2 cosine squared x minus 1. 2 cosine squared theta minus 1. Cosine of theta is negative 3 over 5. 2 times negative 3 over 5 squared minus 1. 2 times 9 over 25 minus 1. 18 over 25 minus 1 is equal to negative 7 over 25. Okay, so what we did numbers 1, 2, 3, 5, 8, and 11. You have to do all the remaining ones. Now, once again, we did number 5. 6 and 7 have the same triangles as number 5, so those are going to be really easy. This is due, today's Friday. This is due Sunday night. You guys have been doing great with handing everything in, uploading it to Google Classroom. Okay. I hope you're all doing okay. Seems like we're in this for a while. I miss you all, and I hope you're doing okay. Take care, everybody. Good night or goodbye. Excuse me. Good afternoon. Good morning, wherever time you're watching this.